All right, what we're going to do now is we are going to do some sample. We're going to actually do your homework. So remember, your homework needs to be done on your paper, and you could do it on the right side of the printed paper the way I've done. And let's get this back to single screen. Just a sec. Okay, I just had the question, can you do this on your own sheet of paper? Absolutely. Some people like to do it on the back of the printed sheet. Some people like to do it off on the right side of the printed sheet. I'm fine with all of that. The important thing is that you recopy the equation. Okay? So let's use the shade so that we can focus. There we go. So now we can focus. Those of you at home, you want to be sure that you correct this particular problem, number 9. It should be CO2 instead of 1O2. Other than that, everything I think is fine. This is a commercially produced product, and see, even they miss sometimes. So here we go. Balancing an equation. What are we looking at? Remember at the beginning of first semester, law of what? Conservation of mass. Yes, law of conservation of mass. So that means that the number of atoms on each side must be the same. And that's what balancing an equation is all about. And the best way to learn to balance an equation is to balance an equation. So here we go. Yeah, Paul, did you have a question? Oh, okay. So first thing I want to do is make sure that we understand what this means. What does that subscript do? Number of nitrogens. Okay? And so this applies to this guy. So how many nitrogens do I have on the left side? I have 2. I do. And now over here, how many nitrogens do I have? 1. How do I fix that? Oh, okay. You want to put a 2 over there. I think that's a great idea. Let's do it. Now when I put a 2 over there, what does that do to the hydrogens? Okay, you understand. That 2 follows the math thing that you do in your math class, distributive properties. Okay, so it distributes to both of those guys. The 3 that you see right here, that 3 only goes to the hydrogen. It does not affect the nitrogen in any way. And this N and H3 is actually a ratio. It's 1 nitrogen to 3 hydrogens. Okay? That's what that means. That ratio cannot be changed in balancing the equation. So, what we do is we say, now, how many nitrogens? And hydrogens? 6. Okay. So, our nitrogens are balanced, but our hydrogens are out now. So, how do I fix the hydrogens? Go. Times 3. 3 times 2 is 6. Okay? And so, this 3 times this 2 is 6, and this 2 times this 3 is also 6. So that's the hydrogen, and the ratio of hydrogen to nitrogen now is 2 to 6, isn't it? The ratio was 1 to 3, and when you multiply that by 2, it becomes 2 to 6. Did I lose anybody with that? Good. Okay, now let's check. Do a final check. Nitrogen's on the left. Nitrogen's on the left. Come on. I want choral response. I want to hear that on the video. Come on.
1, 2, 3,
Okay.
Let's go.
Come on.
1, 2, 3,
Everybody.
Oh my God.
2 nitrogens. Okay. How many nitrogens here?
2.
All right. We're starting to get it. Come on, more of you. How many hydrogens?
3.
6. 3 times 2 to get 6. Okay. And so on this side we have hydrogens. Okay. It's not 3. It's 3 times 2. Okay. Now everything's balanced. Now you can put this in. The reason I'm having you do the coefficients, a number, whether it's 1 or any number, is because when you take multiple choice tests, this is the way the ratio or the answer would be. They would give you this blank. They'd give you the equation blank, and then what they would say is, what's the proper ratio? And the correct answer would be 1 to 3 to 2 for this equation. You have to be able to recognize that. Now, if you don't put ones in here until you get experience, you might, under testing conditions, be nervous, and you look at that and you say, oh, there's no nitrogens on the left. So you would have 0. You would fall for this answer if you did that. That is not the answer. Okay, so if you fell for this, you'd miss the question. And by doing this, I'm hoping that you will not miss that kind of question. Okay, let's get right on to this guy. Get rid of these. All right, how many potassiums on the left? Potassiums? This guy. Okay, potassium's on the right. Okay, chlorine's on the left. On the right. Wow, we're doing great, aren't we, huh? Okay. I think oxygen's going to be a problem. What do you think? Oh, yes. I'm going to show you a trick that you can use. You can take this 2, excuse me. You can take this 2 and use it for a coefficient for getting this guy to be 6. And we're going to put that right there. Then we're going to take this 3 that you see right here and use it for a coefficient over here. You're kind of crisscrossing. Okay, this is another form of crisscrossing. And now you can see 3 times 2 is 6, and 2 times 3 is also 6. Same as in algebra. Okay? 2 times 3 is the same as 3 times 2. Now that our oxygens are good, what about our potassium? How many do we have now of potassium on the left? 2. Over here, how many? 1. Okay? Okay. So the chlorine is 2 over here, so we got to make it 2 as well. When we put a 2 there, we take care of both potassium and chlorine. And now we have a balanced equation. How we done? I hope it's making sense. Let's go on and go a little further. Yes.
So the ratio would be 2 to 3?
Yes. For question number 2, or for problem number 2, our ratio is 2 to 2 to 3. And at this ratio here, that's where you see the arrow. Okay? You have 1 reactant and 2 products.
Do we have to put the arrow?
No, you'll never see the arrow on the quiz. I just wanted to show you where the arrow was. That's all. Okay? Let's go to the next one. Sodium's on the left. How many?
1.
Okay, sodium's on the right.
1.
Okay, come on, all of you get into this. It will help you a lot. Chlorine's on the left. Come on, everyone.
1.
Left.
Oh.
Chlorines on the left is 1. On the right we have 2. How do we fix it? Got to put a 2 here. Now that we have 2 sodiums, we got to fix sodium on the right, don't we? So we have to put a 2 there, make the sodiums the same now. But look what happened. In putting the 2 here, because it distributes to both, we wind up with 2 fluorines, and we got 2 fluorines on the left. Okay? Okay, so what we do is now our fluorines are good, the chlorines are good. We got 2 chlorines here, 2 here because of the coefficient, 2 sodiums here because of the coefficient, 2 sodiums here because of the coefficient, 2 fluorines, and when we put the coefficient here on sodium chloride, we got 2 fluorines. Now we can put the 1s in, because we know that everything is balanced. Okay? How we doing? Yeah? We're good? Okay. So, what we do is, in this one, let's check out the hydrogens first. When you're balancing, you have to focus on one atom at a time. You can't focus on a whole molecule. So, let's look at hydrogen. We got hydrogen here with 2. Hydrogen here is what? 2. Oxygen on the left? Oxygen on the right? Ah, okay. How do we fix it? Yeah, put a 2 there. All right? So we got a 2 there. And so our oxygens are balanced, but what about our hydrogens? We just messed it up, huh? I call this ping pong. The ball goes to one side of the table, like the left side of the equation, and then it gets shot back to the other side, and we have to fix something on the right. Okay? So we fixed something on the right. Now we got to fix something back on the left. What do we do to fix our hydrogen balance? 2. Okay, good. And we are in balance. After we're sure we're in balance, we want to go ahead and put a 1 on the blanks. So be sure and write these underlines. Okay, I want you to write those underlines when you copy those equations. Okay, here's our 5th one. And we might have time to do the 6th one. I think we will. That's good. Okay, so silver on the left. Oops, I don't have the whole. There we go. I was going to say, where's silver on the right? Okay. So, silver on the left and right, are they in balance? They are. Okay. So, nitrate. This guy. How many on the left? Nitrate. 1. The right answer. How many were thinking 3? Be honest. How many were thinking 3 nitrates? Anybody thinking that? All right. Thank you for being honest. And so that's a common problem. Let me show you what it means over here. I'm going to write on the left side of the screen now. NO3, because over here we have a subscript of 2. This is what this means. This equals, there's 2 of the NO3s. NO3 is a ratio of nitrogen to oxygen in the nitrate ion. I think maybe now you're starting to understand why I want you to memorize the ions. Okay. So, if I have 2 nitrates on the right, how many do I have on the left? Oh no.
Oh,
Nitrates. On the left, you do not have 2.
right.
Okay. On the left, we have 1, so we need it to be 2. Now we messed up the silver, didn't we? Ping pong again. And so we go back over and we have to put a 2 here for the silver. Now, since silver is tied up with chlorine, let's check our chlorine out on the left-hand side, which is actually the way I've written it above. So the chlorine, look here. We got a 2-fer. How nice! 2 for 1. Yeah, 1 balancing took care of the silver, and it also took care of the chlorine. Isn't that cool? And the magnesium, what do we have on the top side here? 1. What do we have down here? By golly, we're balanced. So what do we do next? Put the 1s in on the blanks. Ta-da! Okay, 1 more. Here, let's see if we can get this to go down. Yeah, okay, great. There we go, our last problem that we're going to have time for today. Aluminum bromide with potassium sulfate makes potassium bromide on the right side of the equation and aluminum sulfate. Ah, look at this. Okay, you got that 3 out there. What does that mean? How many sulfurs and oxygens? 3 times 4 is 12. Okay. So, aluminums. We're not balanced, are we? 1 over here, 2 here. How do we fix that? Yeah, we got to put a 2 over here. All right? And now how about the bromines? We got 3 bromines on the left. How many are down here? Okay, so how are we going to fix that? Times 3. Yep. So we got a 3 here. Oh, look! When we fix the potassium, we also fix the bromine. How many bromines are on the right side of the equation now? Right here. 3. How many are up here? Oh, we got a problem going here, don't we? Okay, so we really need, I should have put this as 6, didn't I? Shouldn't I? I wasn't thinking right. This should be 6. Okay. Now our bromines are okay. And how do we fix our potassium and potassium sulfate? Times 3. And guess what we just did? We now have 6 potassium and 6 potassium on the other side, but we also fixed the sulfate. This happens a lot with equation balancing, which is very nice when it does. Okay, so I have 3 of the sulfates, which are SO4, and looky here, 3 sulfates. We are balanced! Hurrah! Oh well. Alright, so now we can put in a 1, can't we? With the aluminum sulfate down here, and we are done. I hope you find this helpful, and come in for help if you need it, but I think having done these 6 problems, I think you're going to be in pretty good shape for doing the rest of these. And I hope you found this video helpful.